Welcome to today's podcast on factoring, difference of squares. Today we're going to learn a new technique. So this is the difference of squares. Difference meaning subtraction, and squares meaning perfect squares. So it's to our benefit. Let's write a list of all of our perfect squares that we know of. We'll start with 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 is 25, 6 is 36, 7 is 49, 8 is 64, 9 is 81, 10 is 100, 11 is 121, and that'll probably be enough. We do 144, and 13 is 169. Alright, so we're looking at quadratics that are two different perfect squares. So we might have something as simple as, let's say, y equals 27 x squared minus 75. 27x squared minus 75. You can say to yourself right away that 27 is not a perfect square, neither is 75. But the first thing we always want to do is to try to take out any kind of number we can if they both are divisible by something. And right away I notice that they're both divisible by 3. So I'm going to start by taking out a 3. So y equals 3. 3 times 9 is 27 x squared, and 3 times 25 is 75. So I can pull out a 3. And now I think about my perfect squares. I know 9 is a perfect square. It's right there. And 25 is a perfect square. Alright, so I'm going to first do this by the rainbow method, and then I'll explain how to do it, the shortcut technique. The rainbow method would give me 9x squared minus 0x minus, plus 25. 9 times 25, I don't know that off, so I'm going to multiply, is 225. And my middle value is 0. So I need two numbers that multiply to be 225 and have to be 0. You can see right away that's going to be pretty tough. I know it's going to be the square root of 225, which is 15. It's 15 times 15. One's going to be, oh, this is negative, so one's going to be negative. Negative 15 and positive 15 equals 0. We could go through our whole technique of doing 1, then 2, then 3, then 4. As you can see, it would take a while. So this gives me 3 times x minus 15 times x plus 15. Our leading coefficient is 9, so divide everything by 9. 15 over 9 simplifies to 5/3, so it's 3 times x minus 5/3 x plus 5/3, which again simplifies down to 3 times 3x minus 5 and 3x plus 5. Alright, that's the long way. That's the rainbow method. It does work. It's just kind of time consuming, and there's a pattern that I want to point out. So I'm going to erase this. We ended up with 3, 3x minus 5, 3x plus 5. What I want you to notice is that 9, the square root of 9 is 3, the square root of x squared is x, so that's right there. And also 25, the square root of 25 is 5. That's also right there. This is also right here. So the shortcut method is to take whatever's squared first and take the square root of it. Square root of 9x squared is 3x, and then take the square root of the second number of 5. This only works when you have the difference of squares. Right here is my difference. This would not work if it was x squared plus 25. It's a very common mistake as you do a bunch of these. All of a sudden students think you can do that, and you cannot. It will not work. There's a different technique we can do to do that, but this technique only works with the difference of squares. Alright, here's our next example. Let's do y equals 405 x squared minus 125. Right. So the directions will be rewrite in factored form. So the factored form. So I noticed right away 405 and 125 are not on my perfect square list. But I noticed they're both divisible by 5. That's an obvious choice. So let's divide both by 5. This gives me y equals 405 divided by 5 is 81 x squared. 125 divided by 5 is 25. Alright, so now I notice, oh, I forgot my 5 out here. Can't lose that 5. So now I notice 81 and 25 are both on my list. 81, 25. So this is the difference of squares. I have a minus in the middle. That's good. So let's factor it. So it's going to be 5. 81 is 9x. Square root of 81 is 9. Square root of 25 is 5. So minus 5. And 9x plus 5. Easy enough. Let's do y equals negative 363 x squared plus 300. And I want you to find the roots. Okay, so the first thing I'm going to do is I'm going to transform this to a standard form into a factored form. So first thing, these aren't perfect squares. 363 and 300 aren't perfect squares. So maybe if I divide something out. Also, what you want to notice that this is plus 300. That's not going to work. But notice we have a negative 363. So let's go ahead and divide and see what happens. I'm seeing 3 plus 6 plus 3. That's going to be divisible by 3, and 300 is divisible by 3, so let's do that. But I'm going to divide by a negative 3. Maybe that'll help out my sign issue. So y equals negative 3. 363 divided by 3 is 121 x squared. And 300 divided by negative 3 is going to be negative 100. Let's do a check. Is 121 on my list? And there it is. And is 100 on my list? There it is. So this indeed is a difference of squares. So I'll go ahead and do that. We're going to do y equals negative 3. 121 square root of that's 11. So 11x minus 10 and 11x plus 10. Okay, but this asks me to find my roots. To find my roots, I have to actually set these all equal to 0. So I'm going to say 11x minus 10 equals 0. 11x plus 10 equals 0. Add 10, so 11x equals 10 divided by 11. X equals 10 elevenths. And this one equals x equals negative 10 elevenths. What does it deal with at negative 3? I can say negative 3 equal to 0, but that's not true, so that's not a root at all. So my two solutions are x equals 10 elevenths and x equals negative 10 elevenths. And that's all there is to it. I would try the practice worksheet I put onto the website. That's part of your homework. Have a good night.